All right, well, thought I'd do a couple of questions of the day from different areas of mechanics. So this one's from acceleration and velocity given as functions of displacement rather than as time. So the question is, the velocity of a particle moving along the positive direction of the x-axis is given by v equals 8 minus 3e to the minus 2t. Show that the integral of v over 8 minus v dv is equal to the integral of 2 dx. Find the distance travelled by the particle as its speed increases from 0 metres per second to 7 metres per second. So let's go back to question 1. Show that that integral equals that integral. All right, maybe we should work backwards. Maybe we should go, let's see what would happen if you unpick that from where you normally go when you take a split integral where you've divided it into the v's on one side and the x's on the other. And let's see what we get. And then we might be able to build backwards from there. So we're basically, oh, sorry, that pen won't show up. We're basically being asked to show that then v on 8 minus v dv equals 2 dx. So we're being asked to show, if I swap this around, that dv dx, I'll divide by dx and I'll keep the v there, is equal to 2 8 minus v. All right, so if this is true, then this is the case, and if this is the case, then this is the case. And the reason I did that is I've got v dv dx. v dv dx is one version of our acceleration, and that's, we've got acceleration and velocity as functions of displacement. So that's a really good thing there. So we're saying that the acceleration should be equal to 2 8 minus v. If that's true, if we can get the acceleration to equal 2 8 minus v, then we can go backwards and get to there. So I'll start with what I've been given in the question, which is here. I've been given that the velocity is 8 minus 3e to the minus 2t, and I'll try and get the acceleration and see whether it works out to be that. So the velocity is 8 minus 3e to the minus 2t. So the acceleration is dv dt, and that will be 6e to the minus 2t. Okay, now if you look at this velocity that you've been given here, right, you can see that you could rewrite that as 3e to the minus 2t is equal to 8 minus v, just by rearrangement. So that means that 6e to the minus 2t is equal to twice that. I just doubled both sides. So that's true. 6e to the minus 2t is 2 8 minus v. Remembering that dv dt is indeed the acceleration. So I've started with my velocity, I've differentiated to get the acceleration, and I've shown that the acceleration is twice 8 minus the velocity. So this is really where my answer starts, but I did this bit just to be able to figure out how to go about the question. But now I'm just going to follow that route backwards to get to there. If this is the case, then v dv dx is acceleration, it's one of the forms, is equal to 2 8 minus v. And so swapping that around, v on 8 minus v dv equals 2 dx. And then, of course, the next line down, but I'm running out of space here, but the next line down would be to pop those in front, and we've shown what they asked us to show. We've gone and given them what they wanted. Now, I'm going to need to erase that to use that, but if you need it, of course, you can rewind and go back onto that information there. So the second part of this question probably wants us to use what we just found. They're not always like that, but that's a pretty common thing. So find the distance travelled by the particle as its speed increases from 0 meters per second to 7 meters per second. All right, let's start with what they've given us. V8 minus V dV equals integral of 2 dx. What if we perform that integration, and what will we get? Well, we'll get velocity and displacement. We'll get the velocity as a function of displacement, and that's what question part 2 is about. Find the distance, which is an idea behind displacement, as its speed does something, which is an idea about velocity. So I think we should follow their lead that they've asked us and do that integration. Now, you could easily rearrange that to 8 minus v on 8 minus v, minus 8 on 8 minus v. Or you could do a polynomial division. You know, you could go minus v plus 8 is going into v. So I need minus 1 of those. That'll give me v minus 8, and I'll get a remainder of 8. So you could do it that way as well. I'm just going to write integral of 8 minus v on 8 minus v. But what I've done there is I'm confusing myself around a bit. So I'm just going to follow what I've done over here, because I know that v on 8 minus v is equal to minus 1 plus 8 on 8 minus v. I know that's the case. So I'm going to write that down here. Minus 1 plus 8 on 8 minus v. But you should, if you don't get befuddled like I just did, be able to do that just in your head by making the top line be minus of 8 minus v. Yeah, minus of 8 minus v. You could just do it without a polynomial division. But if you're like me, do the polynomial division just to make it just stress-free. All right, and this is the integral of 2 dx. So we've got minus v and minus 8 natural log of 8 minus v equals 2x plus some sort of constant. I'll call it c. I'm going to erase away this polynomial division so it's not confusing into it. So the derivative of the bottom is minus 1, so I needed to put a minus out there. But otherwise it's a natural log then, because that works out nicely. So that's what we've got. We just need to sort that out now so we can have velocity and displacement function there that we can work with in the context of this part of the question down here. So what are we going to do there? We want to find the distance travelled. So I guess what we've got is that x is equal to minus v minus 8 ln 8 minus v some constant. I know I had plus c and this should be minus c, so I'll just call it some other constant now. And that'll have to be divided by 2. So I know I have that situation there as a rearrangement of that to give me the displacement at a certain point. Now, when v equals 0, we're traveling from 0 to 7. So when v equals 0, x is equal to 0 minus 8 ln 8 minus 0. So minus 8 ln 8, absolute value of 8 is 8, plus k on 2. And when v equals 7, x equals minus 7 minus 8 ln 8 minus 7 is 1. ln 1, isn't that 0? Well, anyway, it's in there, plus k on 2. I never found the value of k, but it's going to be okay because I want the distance, so I want to know the difference, and it'll subtract away. So I just need to erase this top bit here now because I've used that, and I just need to find the difference between these two values here. Okay, so when it's out at when velocity is 7, this is minus. So the distance is the difference here. This is minus 7 plus k on 2, because natural log of 1 is 0. And then minus, so that's one displacement. Take off the other displacement, minus 8 ln 8 plus k on 2. So it's like minus 7 on 2 plus k on 2, and then plus 8 ln 8 on 2 minus k on 2. So that's good because they will disappear. They'll disappear in the subtraction process, and you'll get minus 7 plus 8 ln 8 on 2, which is whatever value that they want. I'm not sure. They didn't say how they wanted that answer given. Find the distance travelled. So that's fine. I'm just going to check what that might be, just as a decimal, just for interest's sake. 8 ln 8 minus 7 divided by 2. It's about approximately 4.82 metres that it's travelled. Now you might ask, well, how did you know you could just do that subtraction? How do you know? Because we're talking distance, and it's not always the difference in the displacements that gives you the distance. For example, if I travel from here in the classroom at Mittagong up to Sydney and then come halfway back, I might have travelled 120 k's up to Sydney and then 60 k's to halfway back at Pheasant's Nest or whatever. So I would have travelled 180 k's. That's my distance. But if you just looked at the difference in the displacements, it would only be 60 k's from here to Pheasant's Nest, like the final displacement. So what I guess I would like to know for sure here is that I guess it was an increasing function. I could do a picture of the velocity versus, like I could have the x vertical and the velocity horizontal and see what goes on there. So if I'm trying to do a picture of the graph that we were just talking about, if that's 7 there, what's going to happen is it's going to increase up like that. And we found from the, this is velocity, and this is displacement, and we found that from 0 up to 7, the velocity is always increasing. And so we can go, well, there was the displacement at that point, and there was the displacement at that point, and we can find its difference. You might want to have a look at those equations, this one and the one that was written there for displacement and velocity on Desmos, and see if you can do a better job than that one off the top of my head.